Are there any questions? Yes, go ahead. Come up to the microphone. But we need you to come up to, I'm sorry you have to come up to the microphone, but it's the only, the session's being videotaped, and the feed for the sound comes through the microphones. So if you just talk, we won't record. So please.
Lee Richard. Is that on?
Is that on?
Is it on?
Yep, we can hear you.
All right. Lee Richard, Owens Corning. My question's a little bit long, so bear with me. I don't know how to aptly think about IIoT, right? Because I don't know what it is. So the parallel I would make is to safety. Owens Corning in general, safety is really a prerogative, and they encourage employees to take safety home. So over the years, the way I look at a parallel to Internet of Things safety is, Internet of Things security is how I treat safety. I have kids, and when they were little, my perimeter defense was the house, right? They didn't move. They didn't do much. They didn't walk. I didn't need to worry about safety shoes and tripping hazards or anything like that. They were little. So my perimeter defense was my house. As they grew up, now they go outside, they go to events, school, church, whatever. And now my perimeter is much larger. Now they need to go by car somewhere, they walk, I'm worried about the shoes, right? Eventually they'll be older and fly somewhere. Now I'm worried about what kind of planes they're traveling on, taxis in foreign countries, foreign cities, etc. So little by little, from a safety standpoint, I'm more and more concerned, and the way to handle it for me is really to embed safety by design thinking into them. Is it something similar here where really federation is the key? Just like you have authentication to log on to a system, but then you've got federated authentication to log on to systems from outside, multiple systems, where you're doing a lot of federation. Is it apt to think of security in that same way, federated cybersecurity, where it's not just devices, but it's the transmission between devices, it's the mobile device is going to access the data, it's the things that's going to supply it, and it's the overall network, cellular or otherwise, that these things are transmitting through. Is that a good parallel to look at it? Because I heard a number of you talk about device security, but isn't it a lot larger as well? And then also if you could talk about this concept of federated cybersecurity. Thanks.
Does anyone want to respond to that?
I'll say a couple words and pass it over. Xavier. Absolutely agree with you. This is not just a device problem. This is not just a cell phone network problem. This is a system level problem. Our basic assumption within GE is that the future of the control system, all control systems, will have a cloud and an edge component. And the cloud brings that elastic compute and elastic storage environment where you can build sort of that ambient intelligence that makes you more productive in your control system on the plant. And why does that happen? Because as you collect and organize the world's industrial data, you can start to tease out the recommendations that are based on experience so that people can make better day-to-day decisions. In that cloud edge environment, where a portion of the recommendations are coming from the cloud and a lot of the local control is happening at the plant, your interfaces are looking at both simultaneously. And you have to be securely authenticated both within the cloud, whether it's public or private, and in your control system. And to do that, you have to have some very extensive secure by design principles in place. And so you're absolutely both in the device, between the device and the clients, between the clients and whatever gateways or other mechanisms you use to the cloud, and even up into the cloud. And it's a system level problem and it has to work together. So completely agree with you.
Yeah, I would totally agree. I'd add, there's two ways of looking at the problem. One is to say that every device, every user, every plant, everything that's connected has to prove trust. The other way to look at it is say, I'm just going to assume everyone's untrusted. And if you just make the assumption for a moment that every device is connected or everyone's trying to connect is untrusted, then you can separate your ICS from your data. And now you create an isolation. So that I believe the key is to isolate all the connecting devices, isolate all the users, and isolate the plants, ICS. So that way there is no direct attack surface other than, if you attack one device, you do not get control of the SCADA system. It won't happen.
Anybody else want to?
Yeah, I don't have anything to add to that. I just want.
To talk.
No,
Sorry.
I got your perimeter analogy with your kids, but when they were young, what was your anomaly detection system?
How many kids do you have? 2? I have 7. It's a big problem.
See, the attack surface is exploding.
That's right.
It's exponential. Yeah.
I don't know what else to say. What's that? What's that?
Thing one, thing.
Thing one and
Thing 1 and
two.
thing 2? That's thing 7, thing. I'm not sure what you mean by federated cybersecurity. Can you expand? What do you mean by federated? I'm thinking Star Wars right now.
Yeah, no, just to make the parallel to federated authentication, just the idea that it's not just the single system that you're trying to get into or the single device that you're trying to get into secure, et cetera, but the whole ecosystem that at the end of the day needs to be secure.
Mm-hmm. Yeah. Yeah, this is really, it's kind of hard to have this really good dialogue in this because, you know, I've sat down with some of you under NDA, some of you not, but just to describe the complexity of a system, a holistic cybersecurity system, takes many, many hours, but it is a very, very holistic, complicated issue that you want to simplify and make it invisible to the user. But it does require a fairly sophisticated authentication. So again, if you have a deep root of trust in the edge devices, the whole myriad of them, and you have then an authentication process and a key management process. So you have these keys that allow you, these crypto keys that allow you to say, to allow some kind of a transaction. Then the key management process to, for instance, in the case of when the technology that we've built, the microcontroller has a series of keys that are secure in protected memory, crypto keys, and then the device lifecycle management system authenticates the controller, the microcontroller, to the board, authenticates the board to the module, authenticates the module to the system, authenticates the code to the module, and authenticates transactions and applications to the system. So it's very much a layered system, and it's pretty complicated to describe, but once it's all in place, it needs to be transparent, you know. So I don't know how else to add value to you in that, but.
Did you want to say anything, Bill? No? Let me follow up with all the comments here. You know, because I came from it, the secure device, secure communications. I think what most people expressed here is more a secure, and I'll give Lior credit for this term, he mentioned it to me earlier, secure architecture kind of a thing, meaning all of it has to be secure. But let me just throw one thing back at you that I wonder about. You know, today, and particularly if you think from the control system paradigm, it's a controlled environment. I mean, it's not only secure perimeter, I'm not saying that, but it's something you know exactly what's there, somebody can engineer it, someone can say this software belongs in this, or this device communicates with that, stuff like that. So it's a very engineered, controlled kind of situation, okay? And I mean, to me, securing that is probably no different than securing a control system today. It's just that maybe you have to deal with other issues because you're going out on public lines and encryption, things like that. But I just have this vision, and maybe it's wrong, probably, but that it could end up being a much more fluid kind of environment. And an example of what I mean, for example, I mean, I do think that people will have devices, whatever they are. Maybe they're embedded controllers in some type of a piece of equipment that's important to you. At the gas station, all right? That tank, whatever the fuel tank the control system was, all right? Now, I picture in the future that somebody's going to go up to that and maintain it by going up with their laptop, and they're going to connect through Wi-Fi or something like that. Now, That's not something that you maybe you could sit down and consider that one situation. But I think there's a lot more device-to-device communications and a lot more fluidity in the architecture. And so I don't think, so my point is simply that it's one thing to sit there and say, I'm going to think of all the things that can go wrong, all these are my pieces, how do I secure all of them as an engineer? I'm an engineer myself. But it's another thing when you say, I don't know what's going to be in there. I don't know what's going to connect to what. I don't know how it's going to connect. In that, for me, it falls back to say, the only thing I can do is make sure that each of those pieces has all the security it needs itself to take care of itself. You know, it's more of the extreme case of, like today I made the point about the control system. I'm sorry. Oh, I didn't even see you there. I apologize. But in the control system, you know, where I made the comment about a lot of people today in ICS cybersecurity, you're taking advantage of knowing the topology of the network you are in and the security that's above you. I mean, I talk to lots of people, you know, it's the defense in layers. Well, in this case, the networking kind of layers. You know, that I have firewalls here and this one, so what can get down here? So I don't need that security there. This is more where you can't make those assumptions because you don't know what's going to happen. And I'm just wondering if maybe I just am way off my base, that the world's never going to be like that, in which case I guess I don't have to worry about it. Or if I do, what do I need to do for a device to make sure that it's secure and that the networking is secure? Now, maybe you don't want to answer that question because maybe it's off base. I don't know. Does anybody want to comment on that, or are you just going to leave that one go?
Actually, my question is very much around that.
Oh, and then please, you ask your question.
So basically, does it work?
Can you turn that? Oh.
Okay. Hey, my name is Michael. If I look at kind of analogy, and every analogy fails, but so if you have a vessel and you want to prove it's watertight, what do? You put water in it, put it under pressure, no water leaks out, so you're good to go. So same thing here. How do you know that your Internet of Things, that the connectivity is secure? And so what I've heard until now, it's only secure until it's proven unsecure. But is there kind of a smarter way that you kind of, say, well, if you follow this protocol or if you do this, then you know for sure that it is okay, like 99.9997. So do you have an advice how we can?
I would add a couple of things there. From a hardware standpoint, now I have a background in wireless, so I understand a bit of the challenges from when it comes to securing a mobile gateway, for instance. Very few people realize that today you can actually send an SMS to a mobile gateway and it'll actually wake up and go and load some software. Very strange as it may seem, but it was designed for the reason that they needed to be able to have remote access to the device. And the carrier's position, and if there's any carriers in here, I apologize, is that our network is secure. You can never get on my network, so I'm going to secure it using my network. Meanwhile, if I send it an SMS, I can tell it to go to any network. I don't know if there's a certification band or if there's a way to certify that a device is secure, but if you just follow the simple rules. One, don't open any inbound firewall ports. The device should have a firewall at best. If it doesn't have a firewall, then there should be no way to remote control it, i.e. you can't get into the device, period. And two, turn off any remote monitoring capabilities on it, or three. And four, if you have a software partner who says that they can remote monitor it, you need to test how they're going to get into it. Because if you're going to get into that device, that means somebody else can get in as well.
Lior.
Can I jump in quickly?
Yep.
Oh.
I think we're going to fail if we try to treat this as one problem where everything that we classify as industrial Internet of Things is going to have the same level of security and the same level of certification, accreditation, whatever you want. I mean, you can tie this, if you look back at the financial industry, they accept what most people would consider a sizable level of fraud because it's an acceptable level of fraud to them, whether it's 3% or 2% or 4%, but they do this, and a lot of what we classify as industrial Internet of Things will have a pretty minor impact on people's lives if it is compromised. And I doubt we'll be securing those things as much as we're securing some of the factories and mines and other things that could have big safety, big financial impact. So I think it's dangerous for us to say we need a solution that we're going to put in every product that'll be the same. I mean, we actually have some experience with this as well with the smart meters that have gone out. I mean, there's a big difference between a smart meter that allows remote disconnect that could potentially knock out the power to a lot of places, and a smart meter that's just getting, or a smart meter that's just getting readings where you've got back-end algorithms that can, detect when a reading is out of whack and automatically bill someone a projected reading until it can actually be read. So I guess I don't have the answer to your question, but I guess the question bothers me a little bit if we start looking at it as we need a way of securing everything in the industrial Internet of Things with the same types of security primitives.
Yeah, I too have criticism about your question.
Thank you.
I think, first of all, that you cannot secure anything, period, and say you are secure. It's a bit different. You gave the example of how do I know if it's airtight, but when you are thinking of it from the same example from a let's call it a cybersecurity issue point of view, so you're not just asking if it's airtight. You're asking, okay, but now let's say that I tested it and now somebody intentionally starts to poke holes in the boat or starts to, I don't know, do bad things. And what happens if I crash into an iceberg? And what happens, these are the questions that your test that said I'm secure or I'm safe didn't answer. And you can never answer those and say, okay, I am secure. It's a process that you always need to reevaluate and move forward and assess new risks and learn from those that happened, things that happen to others and things that happen to you. You cannot be secure and move on to other issues. It doesn't happen.
Makes sense what you say.
Yeah.
Okay.
I would tend to agree with that there's not one solution that fits all. And just, a couple of examples. I think we also, like yours, I felt that the VPN-based solution has too many pitfalls. But it was, the best of the industry for some period of time. And we've started to replace those throughout with, connectivity that doesn't involve a VPN because it's a more secure approach. Now, when it comes to the SCADA systems, most SCADA systems, any client can connect to the SCADA system. And once a client is connected, it can do all kinds of damage. Understand that's an attack from within, but Stuxnet and some of these attack vectors were from within, not from without. And so, we're moving to an OPC UA-based architecture with a global discovery server that exchanges certificates between the client and the servers to make sure that that's an authenticated and a secure connection between the two. Now, is that guaranteed to be safe in all cases? I can't mathematically prove that, but it's significantly better than what we have today and will evolve from that kind of endpoint. When it gets down to the controls, the same kind of thing. Those have been wide open for many, many years. But now that we can put, the trusted control modules on there, and we can store keys, and we can have a secure, authenticated connection to it, and make sure that when they boot up the program that's running, that's significantly better than it was before. And as we understand the new attack vectors that emerge, we'll continue to try to address those. So I don't think this ever ends. As good as we get, sort of the bad elements that are out there are trying to stay a step ahead of us.
Please.
Hello, I'm Kevin Davenport with Cisco. Real time is always a term that's, I don't know if it's overused, but it's commonly used in the industry. And with security, there's always some overhead associated with security. So outside of just the perimeter strategy, one of the holes I see is those mission critical applications or mission critical devices. Have you guys put any thoughts around addressing those holes that might be accessed because people just know that mission critical apps aren't as protected or involved? That's a basic question.